factoring and solving quadratic equations. So the last two types of factoring that we're going to look at are factoring difference of two squares and the sum and difference of two cubes. So they both have like a formula. So when you see a problem that's in the form a squared minus b squared, and that minus is really important. If that's not there, then it can't be a difference of two squares. Then it factors to a plus b times a minus b. For example, x squared minus 36 factors to x plus 6, x minus 6. b, 49m squared minus 1 will factor to 7m plus 1 times 7m minus 1. So you'll notice that I'm just taking like the square root of each part and making it 1 plus and 1 minus. C, 169a squared minus 49b squared would factor to 13a minus 7, or plus 7, doesn't matter which way we do it, and 13a minus 7. And if you weren't sure about 169, you can take the square root of that on your calculator. And the last one, y squared minus 1 over 16, would factor to y plus 1/4 and y minus 1/4. So those are pretty straightforward. The sum and difference of two cubes is just remembering these formulas. A cubed plus b cubed equals parentheses a plus b, close parentheses, times parentheses a squared minus ab plus b squared, close parentheses. And a cubed minus b cubed is equal to parentheses a minus b, close parentheses, parentheses a squared plus ab plus b squared, close parentheses. So for example, 20a is p cubed plus 1. I like to go ahead and identify what the a and the b are. So that's just by taking the cube root of each part. So a would be p and b would be 1 here. And then it's a plus, so I follow the first formula. And it's just p plus 1 times p squared minus p plus 1. Part B, 27y cubed minus 1. Here a would be 3y and b would be 1. So I'm going to follow the minus 1. And it would be 3y minus 1. Or follow the formula with the minus in it, is what I meant to say, times 9y squared plus 3y plus 1. Part C is y cubed plus 64z cubed. Here a would be y and b would be 4z. Again, if you weren't sure what the cube root of 64 was, you can just type that on your calculator. So plugging that into the formula, we get y plus 4z all times y squared minus 4zy plus 16z squared. And I'm just straight up taking the a and the b and plugging them into the formula. Last one, 6r cubed plus 162. Factor out the 6 first, so we end up with r cubed plus 27. Because with the 6 there, it's not a perfect, or it's not a difference of, or a sum of two cubes. Now a is r and b is 3. So we have the 6 on the outside, then r plus 3 times r squared minus 3r plus 9. Okay. Next thing is solving quadratics by factoring. So now that you know how to factor, you factor the trinomial and you make two equations with it, and then you solve each equation. So it's just kind of taking it a couple extra steps further. So 22a is 2x squared minus 10x minus 12 equals 0. So with this one, we can take out that 2 out of each one, and we're left with x squared minus 5x minus 6 equals 0. Now, since we can divide both sides by 2, that 2 isn't going to matter anymore. Since it's an equation now, we can divide both sides by 2, and 0 divided by 2 is still 0. So that's what happens with a coefficient on the outside. Now the inside, you can use any of the techniques that you are familiar with for factoring. And this one works out to be x minus 6, x plus 1. We'll factor it. Take each one of those and set it equal to 0. And that's using something called the zero factor property, which I didn't mention, but it's at the top of the page. That just says if you have two things multiplied together and they equal 0, then one of them or both must be 0. So if I solve this, I get x equals 6, and I also get x equals negative 1. Those are the answers for this equation. Part B, I'm going to do this one using the box method. There's no GCF that comes out of all of them. So I put the 4x squared and the 9, multiply those together, and you get 36x squared. I want factors that add up to 15, so that'll be 12x and 3x. So put those in the boxes. Factor out the GCF of each row, which is 4x and 3. And when I do that, what's left is x and 3. So this one is 4x plus 3 times x plus 3 equals 0. And since it's an equation, we have to keep going. So 4x plus 3 equals 0 and x plus 3 equals 0. The second one's easy. It's just x equals negative 3. This one I have to subtract 3 on both sides, so I get 4x equals negative 3, and then divide by 4. So that turns out to be x equals negative 3/4. So both answers are answers because they both work if you plug them back in. With part C, if I take out a 3, I'm left with x minus 9. X squared minus 9 rather. Now remember the 3 will get divided out, so I'm really just looking at x squared minus 9 equals 0. That's the difference of two squares, which is x plus 3 and x minus 3. And if you set each one of those equal to 0 and solve, you'll get x equals negative 3 and x equals 3. Last one like this. For D, it's x cubed plus 11x squared plus 10x equals 0. I want to factor the x out of each one. So I'm left with x times x squared minus 11 or plus 11x plus 10 equals 0. Now this time the x does matter. That one is going to just get set equal to 0, and that's one of our answers. Now the trinomial in the middle here, that has to get factored. And that's a nice easy one to factor. It's just x plus 10 and x plus 1 will work. And if you don't see that, you can work it out with the box method or however you like. Then each one of those gets set equal to 0. And x equals negative 10 and x equals negative 1. So there's actually 3 answers for this one: 0, negative 1, and negative 10. All right, the square root property is basically just taking the square root of both sides. But there's one little thing with that, is that if you take the square root, you have to consider that there's a negative and a positive answer. So for this one, if I take the square root of 8, my answer, either positive square root of 8 or negative square root of 8 would work. So I need that plus and minus there. And then 8 is the same as 4 times 2, and 4 actually, the square root of 4 actually can come out, and we end up with plus or minus 2 root 2. So that's just simplifying the radical. Part B, we subtract 1 on both sides, so I end up with 4x squared equals 6. Then divide by 4. So that's 6/4, which reduces to 3/2. If I take the square root of both sides, I get plus or minus the square root of 3/2. I can't simplify that anymore, so that is the answer. Not all of these will work out to be nice, neat, whole numbers. In fact, when you can't factor them, you have to either use completing the square, or you can use the square root property. If that's some of them would be easier. If it's just here, let me back up. If your example only has I get my markup tool. Like you notice these two, they're missing that middle term. So using the square root property is probably the easiest way. But if they don't factor and they have a middle term, then we either need to use the completing the square or the quadratic formula for those. It's gotten a little big there. Okay. So completing the square is kind of a long, tedious process. I personally would rather use a quadratic formula, but part of this course is to learn completing the square, so that's what we'll do. In fact, this video is probably getting a little long, so I think I'm going to stop here, and you guys have, oops, what did I do? Go back here. So we just finished solving by factoring, and you also learned about the sum and difference of two cubes and the difference of two squares. I think that's enough to soak that in, and then take a break, and I'll pick up here and the last two techniques, which are completing the square and the quadratic formula, that we use for problems that we can't factor. So we just have those 2 pages left.